Hello guys, I hope all of you are doing fine. Today we are going to discuss our question 132 pattern. So let's discuss it. We are given an array of integers. We are required to check if our array can form a 132 pattern. If yes, we have to simply print true. If not, we'll print false. So first let's understand what our question is talking about. Okay. So what we are given is to check if our array elements can form 132 pattern. Okay. What 132 pattern is actually? Let's see. So let's take in our array we are given three numbers. Let's take an array. I'm gonna create an array. Yeah, I know it's a messy, but yeah. So we are given three numbers: 1, 3, and 2. Okay. 0 in the index, first index, and second index. Now, here we are given in the question that ijk indexing. What is ijk indexing? That here the 0th element will be I, the second element, the first index element will be j, and the third will be k respectively. Now what we are required to check is 132 pattern. So what 132 pattern is here? Let's say this is your nums array. So nums I will be less than nums k, right? Less than nums j. So this is given to us in our question, as you can see. So what this indicates? So this indicates that, let me create some space and tell you that, as you can see, the 0th index will be the smallest, right? It will be the smallest. Here k, right? K and j. So j will be the largest. What I'm talking about, the value. So what will be k? K will be the middle one. The mid of small and large. As you can see here, in the 0th index we got 1. In ith index we got 1. Right. In kth index we got 2. Right. And in the jth index, that is our largest, we got 3. So this is a 132 pattern. Okay. So we checked for 132. Now we'll check for more elements. If any subsequence or of our array follows the 132 pattern, that means we have to return true. Okay, now let's see more example. So let's take 1, 2, 5, 8. So here again, this will be our I, right? This will be our j, this will be our k, right? Also, that's one thing. What you can also say that, see, first we take 1 as I, 2 as j, and k. Do they follow 132 pattern? Do they follow? Do they follow? No, they don't, because if this is our smallest, this is our largest. So here the kth value is not in the middle, right? It should be supposed to be middle, and or you can say j is supposed to be the greatest, right? Or the largest. Okay, now we are going to check for different, we are required to check for all subsequence, right? Subsequence of 3 integers. So what possible options can be? 2, 5, 8, right? Or you can say 1 to 8, right? It's subsequence. It can be 1 to 8 as well, as well as 2, 5, 8, right? So 1 to 8. Do 1 to 8 follow? Do 1 to 8 follow 132 pattern? No, it does not follow, because we can see here j is supposed to be the largest value, the largest, right? J is supposed to be the largest value, I is supposed to be the smallest value, and k should be the middle of both of them. So we will return false. We will not return false, of course. We have not checked all the subsequence for our number array. Now again a different subsequence, that is 2, 5, 8. So let's see if it follows 132 pattern or not. For 2, 5, 8, this is our I, this is our j, and this is our k. So what the condition should be? I should be the smallest. Yes, I is the smallest, right? and j. J should be the largest. Yes, j is the largest, and k should be the middle of them. As you can see, it follows the condition. So for this number, for 1 to 58, we are gonna simply return true. We are gonna simply return true. Okay, let's see more example now. You will get it. If you are not getting it, you are gonna see more examples. So let's say we are given 4, 1, 2, 5. Right. So does it follow? Does it follow our pattern? Let's see. So here I'm gonna show you. We are given 4, 1, 2, 5. Right. 1, 2, 4, 5. So here 4 is here. Let's say 1 is here. Right. And 2 is here. So do they follow? Do they follow? I'm gonna bring this so that you can relate to what I am saying. This whole. Yeah. Mm-hmm. Mm. Let me paste it again. Perfect. So for 4, 1, 2, as you can see, do they follow our pattern? Do they follow? So how? Okay. Let's see. I'm sorry. Yeah. The 4, where 4 is initially here, right? Then 1, then 2, and then 5. So as you can see, no element, no element is following our pattern, right? It is 1, 3, 2 pattern. So what was the condition? That 1 is the smallest, right? Middle one should be the largest and right is the mid. And here none of it is following our condition, right? So it is not a 1, 3, 2 pattern. Let's see more example. Or let's say we got array minus say minus 1, 0, 3, and 1, and not 1 and 2. So do they follow our 1, 3, 2 pattern? Do they follow our 1, 3, 2 pattern? Let's see. So here I'm gonna show you with the help of a bar chart. Minus 1, 0, 3, 2. Right. Minus 1, 0, 2, 3. So here, where will we are? Minus 1 here, right? Then 0, then 3. Now what I want you to notice that 2. Your 2 will be in the middle, right? Your 2 will be in the middle of what? Your 2 is k, and as you can see, your 2 will be in the middle of minus 1 and 3 as well as 0. So this will be a 132 pattern. Right, this will be a 132 pattern. We have to simply print true. Right. So we have already seen couple of examples. If you still don't understand it, let me show you one more example. Okay. So if you are given, let's say 1 or say 4, 8, 7. Right. So let's see, do they follow our pattern? Think about it. What was the condition? It should be the smallest. Right. It should be the largest. And it should be the middle element, right? So there can be multiple 132 pattern of a given array. Of course, there can be multiple 132 pattern. For example, we are given an array, let's say 1, 3, 1, 3, or wait, 1, 5, 2, 3, right? So here, for this, what are these subsequence? So one of its subsequence is 152, right? And one more subsequence is 1, not 1, yeah, I think it's 152. And what else? Yeah, so I think the only patterns that follow 132 pattern is 152. Let's see some more subsequence for sure. So it can be 1, 2, 3, right? Why 1, 2, 3 don't follow? Because You know why 152 is a 132 pattern, right? Because smallest, largest, and mid. So it follows the condition. And for 123, so let's see simply for 123 what will be it? 123, 123. As you can see, your ith value is here, your gth value is here, and your kth value is here. And it is not matching the condition, right? Your gth should be at the top, and your I and your kth should be in the middle, right? So it is not a 132 pattern. So I hope that you have understood the definition of a 132 pattern. Now let's try to discuss the approaches that how we can solve this. So 132 pattern, right? So, as per question, we are required to check all the subsequence of the array provided to us, right? So, let's say we are given an array 4, 6, 2, 5, 8, 8, 7, 9, right? So, here, what we are going to do, this is our first approach, and it's very brute force approach. I mean, you could have already figured this approach, right? Also, for this approach, I will bring it. I have copied it already. Yeah, this. Hmm. Right. So this was the condition num psi is the smallest, num_k is then the middle, and num_j is the greatest. So what we are gonna do? This time we are gonna traverse the whole array with see for int I, let's say our I is here, our j is here, and our k is here, right? So we are gonna run how many loops? 3 loops. For here, then one more for loop here, right? So this for loop is going to run from I equal to 0 till the end, right? Till the end. And this for loop is gonna run from I plus 1, right? Here j is equal to I plus 1, right? Till the end. And the last for loop for k is going to run from j plus 1. Perfect. Plus 1. So using 3 for loops, we can definitely check for each where that if this condition is true. If yes, we are going to simply return true. But of course, as you would have guessed it, as you are understanding it, that this is an expensive operation. Why it is expensive? We are running 3 loops, right? For 4, our j is here, k is here. So first, what is going to happen? See, k is going to traverse whole, then our j is going to increase, right? Then our j is going to increase, get here, then again k is going to traverse, and such that it's a very lengthy process, right? It's a very lengthy process. So it is how much time complexity is going to take. It's going to take O n square, right? O n, not square, sorry, O n cube, as we are running 3 loops here, 3 loops. Now, of course, this time we are going to optimize this approach. Now let's see one more approach. Okay, so yeah, here. Now this time, what we are going to do? Okay, so let's see what. Let's say we are given A, A, B, C, D, E, F, G, H. Right. Let's say this is the array given to us. And here, this is our I, this is our J, and this is our K. So earlier what we were doing, we were traversing for I, J, and K. But this time, what we are gonna do? Somehow, we will calculate, not calculate. No, first let's understand something. So here, we know that I is supposed to be the smallest. Do you agree with me? I is supposed to be the smallest. So here, let's say our value are 3, 2, 1. Right? My j is supposed to be greatest. let's say here my j is 8, right? So what the range, what my I value should be, if what my I value should be, so that I get my answer, right? What's the best possible option that my I value should be? Think about it. So if I get the minimum of ABC here, if I get the minimum of ABC here, let's say we got 1, right? Let's say we take 1. So of course, I will have more probability of my getting my answer, right? So here, let's say I got minimum, that is 1, right? And what is my j? My j is 8. So now also I'm calculating minimum in oven time, right? How? If you have not watched our stocks fan video, do watch this. Do watch that. We were calculating O minimum, right? Here we are going to calculate, just have faith in oven time, right? In oven time we are going to calculate our minimum. So our j is here, and for k, what our k should be? Greater than our minimum and less than j. So for k we can run a loop, right? We can keep traversing. So this operation, I hope you got what I'm trying to say. Again, I want to repeat my words, that I'm going to get its minimum, right? If I'm at D, I'm going to get the minimum, and that is the best option I can give it to my, so that the range gets bigger, right? Now that is my J. So now, earlier what we did, we calculated 3 things, I, J and K, using 3 loops. But this time only 2 loops will be required for J and K, right? For J and K, and minimum we already got, right? So this time it's going to take on square time complexity, right? Its time complexity will be on square. Again, let's say this is our minimum, right? This is our j. So we have got a only traverse for j and k. We already know the best minimum option till the number, till the index, right? Now, now we are gonna discuss one more approach. This time we are going to perform the same thing, but with a change. So again, let's say here we are at D, right? So we will consider this our J, right? And what was the condition supposed to be? Wait, yeah, our condition was that J should be the largest. Okay, so here let me also write some numbers. Let's say J is D is 6, right? This is 3, 2, 1, and here, right? This is K. Let's say, okay, let me mark it so that you understand. So this part is your I, and here this is J. Currently this is J, and all this is your K, right? Let me give it some value. And right, so this time I'm going to use a data structure. What data structure? Tree set. So I'm going to use tree set. So what tree set does is, here if I got my elements in a tree set, right? Let's say I got 8, 4, 7, 2. So if I want, so what I exactly want here, right? For k, what I exactly want is the element which is greater than the minimum. So it's the smallest. Let's say our smallest here is I in this case, right? And we have considered this our largest, our D our largest, that is 6. So now what was the condition? That k should be greater than my I. So for this operation I can achieve in log n time. If I need just greater element, so using tree set, I can get that element using what? Log n time, right? So what will be its time complexity? It's going to be n log n, right? N because we're gonna traverse for j, right? I, you know, that's minimum. We are gonna take a minimum array, right? and k we are going to calculate get using tree set. So this is going to take n log operations, right? Now let's get to the main approach. Okay, so for that I want to discuss some things. Suppose we are given elements again 3 to 5 and this is your 9. Okay, so this is your 9, this is 3, this is 2, this is 5. Okay, so here let's say, of course, we know that for I we are going to consider the minimum, right? So my I is going to be 2, right? When our j is equal to 9. Now let's say I is equal to E is equal to 3, right? So here I need the element that is greater than my I, right? That is greater than my I. So that is greater than my I and that is less than D. So here the condition is true. But what if here is 1, right? What if here is 1? So I checked that 1 is less than what? 1 is less than I, right? For example, here it is 0 or something in minus 0 or minus. So do I need to check for these elements that are less than or E, right? No, of course not. But what if in here you got what? Here you got 11. So 11 of course. Now let me remove this for one case. So here you got 11. So 11 passes the condition. What condition? Sorry. Yeah. So 11 passes the condition that it is greater than Ri. That was 2. But it is also greater than J. That it is not supposed to be, right? J is the largest. So if I traverse, so now can I say that I won't check the smallest elements. Here I was not checking the smaller elements, right? So here, let's say our I here is not, let's say our I here is 5, so that you completely understand what I'm trying to convey. Let's say our I is equal to 5, our J is 9, right? So K, here it was 1, right? So do I need to check elements that are less than my current K? No, not. And here it is 11. So now, but here, if it is more than minimum and even more than J, so I need to check, right? I need to check the elements that are less. So for example, here it is 6. So I will check it and yes, it passes the condition. So why I'm talking about this? So you get the idea that how we can solve this, how we can approach this. So now let's discuss the main approach. Okay, what we have discussed to how we can solve this in O(n) cube time, O(n) square time, and in n log n time. Right. Now we are going to discuss its optimal O(n) approach. So what we are going to do is, of course, create a array. Create a stack. Sorry, array we are already given to us. Right. And here we are going to calculate minimum. Minimum till now, right, for all the elements. So let's write it. So here till 5, what is the minimum? 5. Here for 7 it is also 5. Here it is 5. The minimum till now is 5, right? For 4 the minimum is 4, right? For 9 the minimum is 4. For 3 the minimum is 3, and then 2 it's the minimum, right? So we get the minimum, right? Minimum till now. So we can simply achieve it using a separate array where we are going to store the minimum in O(n) time, right? In O(n) time, but we are gonna get it. I hope you have watched that stocks fan video, so you will get what I'm saying. Or while code, I'm gonna explain you. So we got minimum. Now this time we are going to start from the back. Okay, so stay with me. So first, what we are going to do, wait, I'm gonna create some space, right? We were required to achieve this, right? So I j k. So the my last element is of course k, right? So of course I can't build an answer here, but here I'm gonna push what? I'm gonna push 2. So here I push 2. Now I know that now for 2 I got nothing to check. Alright, I will get to 3. Now comes the important time. So for 3, I checked that my minimum is 3. Is my minimum greater than 2? Right? Is my minimum greater? Yes, my minimum is greater. So what I'm gonna do? I'm simply gonna pop it. Right? And I'm gonna push 3. Now, so here what I want you to understand, that the minimum here that we are storing, the minimum will be our I, right? And the num array, this is our num array, right? The num array that we are traversing, it is our j, right? It is our j. And what will be our k? Our k will be the element that is in the top of our stack, right? Currently, we did the job for 3, right? Currently, our j is at 9, right? So, now you're gonna get it what I'm trying to say, okay? I'm gonna trying to make you understand, right? So here, it is so here we got at value 9. So as you can see that first we are going to check if I, if our top element of our stack, is it greater than our element, right? It is not greater, then of course I should be the smallest, right? So we are going to simply pop this, right? We are going to simply pop this, and then we are going to move j and k, right? And of course we got to push 9 here. Now let's check again. Our j is 4, right? Our j is 4 and our minimum is 4. Of course, okay. Of course, we can see that the minimum, it is less than 9, right? So that matches the condition, but we also got to check another condition. What is the another condition? That the number, the j, it should be greater than k, right? This is k, this is our k. I can write it here, this is our k, but it doesn't match the condition, right? So what did I have to do is to pop this. Here, there's no need for popping. Sorry. Here, I think you might be getting confused, so I want to write steps here. So first, when are we popping? We are popping when our minimum is greater than, the top element of our stack, of stack. If that's the case, we are popping. Alright, if that after, so if that condition is not true, then we are gonna check if our j, right, if our j is greater than the number, right? If sorry, if k, is less than j, right? What is k? The top element of stack. So here I should write top of stack. Top stack. Top stack is less than j. That means j is the greatest. So I'm gonna return true. Right. So that's what we are doing. So let's complete with our dry run. So here my j will get to 10. I will get to 5. I'm gonna push 4. Right. Now again, we are gonna check if I is less the minimum, that is 5. So if 5 is less than, right, we pushed 4. So now we are gonna check if a minimum that is 5 is greater than the top element of our stack. So what we have to perform is pop this. right? Now again, you're gonna check if the minimum is greater than top of our stack, and that's not the case, right? So here, if that's not the case, then we are gonna check the condition. If if 9 is less than j, and as you can see 9 is less than 10, so that is, condition is true, then we have to print true. And as you can see, 5, 10, 9. So yes, that makes 132 pattern, and we have to simply print true. So now let's try to code it, and there you are gonna completely understand it. So our first step is to create the minimum array. So let's create a minimum array of nums dot length. Right, we created a minimum array. Now in the minimum 0, what it will be, that there is no minimum till yet. Now it will be its minimum. So it will be nums 0. Now we are gonna traverse starting from 1 till I is less than n, I plus plus. Here minimum of I will be equal to mat dot min minimum of I minus 1 and nums I, right? So we calculated our minimum just by using this formula, the minimum array. Now next step, what? Now we know that we will be requiring a stack of integers. St equal to new stack. I'm gonna traverse starting from the back. So for int j, this is our j, right? For j is equal to n minus 1 till j is greater than equal to 0, j minus minus. Now, when will we pop? When st dot size is greater than 0, of course. Sorry, right. When st dot size is greater than 0, and as we can see, and when minimum is greater than top of the stack. So here I would like to write two things, that is minimum, right? Current minimum, that is minimum of j. What else? Value, that is value. So value equal to nums array, right? Num j. Now if minimum is greater or equal to, then a top of the stack, right? Minimum is greater than top of our stack, that is what? Value, that is st dot top. If that's the case, then I will simply pop st dot pop. Here it is st dot peak, sorry. Then I want to check if, what was the condition? If top of the stack is less than our j. So what was our j? We are the array, the value. So if top of the stack, if st dot peak is less than value, right? Value represent jth value, then it means it's true. Then what I'm going to use is a boolean array, boolean variable, boolean found, that is initially false. So here I'm going to make found true. So found will be equal to, right? And then don't forget to push st dot push the value nums j, right? And then we have to print what? We have to print found. So let's print it. System dot out dot print ln found. Now let's run it, see if this works or not. Giving error, line 20. Let's see it. Minimum array. If minimum j minus 1. Wait. Go to minimum of j. Min value is equal to min j. So here I'm going to make it min value as we already got a variable minimum. Right. Here also min value. Let's try to run it now. It checked it. Let's see why it got rejected. Okay, so here two things he did wrong. Like here, we should also check if stack size is not 0, right? Because above we are popping, there are chances that stack size is going to 0, right? So and condition. And here, if we got our answer, if found is equal to true, we'll simply break, right? lst.size is equal to greater than 0 and perfect. Now run it. 25th line again. Okay, syntax error. If should work now. Perfect, found. Let's submit it. Wrong answer. So now we are going to discuss the approach we were waiting for, the optimal approach. So first we will require a minimum array, right? What this minimum array represent? The minimum element till the index we are traversing. Let's see what I mean here. So for 5, the minimum will be itself because there's no element before 5. For 7, what is the minimum till now? It's 5. For 6, it's also 5. For 10, it's 5. For 4, of course, 4 is minimum, then 5, so it will be 4. For 9, it is 4 now. For 3, the minimum until now is 4, but this time, as 3 is less than 4, it will be 3. For 2, it is 2. That is our minimum array that we are gonna store, right? So that we get the minimum. And we know that why will be needing our minimum. Also, I would like to bring this so that you understand that what is 132 pattern, right? So it is always right besides you are one. Perfect. Yeah, our 132 pattern. Okay. Right. I is supposed to be the smallest, k is the middle element, and j is supposed to be largest. Now, this time, what we will going to do? So this time we will traverse from the right. Why is that? Because we know that k should be that k should be the middle element, right? So we are gonna traverse our j. For j, we are gonna traverse for j, right? And where k will be? K will be in our stack. Let's see what I mean. So I want to build a stack here. So if you are not understanding now, just stay with me. Eventually you will understand, or also I will write the steps here so that you can relate with me. So what we are going to do now, let's see. First, when we will pop, okay, so here what the minimum array represents. So if I am at 9, for example, if I am at 9, so what is my I here? My I is minimum, right? So my I here is 4, my j is 9, and what is my k? That is the element present in our stack, right? Now I want you to focus on the conditions that we discussed. Nums I is less than nums k less than nums j. Okay, so let's do it. So first we are going to discuss and write steps together. So for 2, right? For 2, we know that there is no k for 2, right? 2 is the last element, so we are going to simply push it, right? Now the important step. Here I'm going to write I, sorry, here it is j, I, and this is your k. This is your current k. Perfect. So our j is 3, our I is 3. Now our first step, we need to know my minimum. My minimum is 3. So the stack element should be greater than our minimum, right? Because we know nums I is the smallest element and nums k is greater. So if nums k, if the top element of stack is not greater, then we simply gonna pop it. So here I'm gonna write the condition if minimum is greater or equal to top stack, then I'm gonna pop it, right? So let's pop it up, and then at the end what we'd always do is push, right? So here we are gonna push our number. So we popped it, and now we are gonna push 3, right? Now here yeah, we get here, and our j and I both get here, right? Now we are gonna check that is our minimum, it is greater than 3. As you can see, the minimum is greater than the top element of stack. So we will do nothing, we will simply pop it, right? And then get to the next element, right here, and I will get here. And now again, minimum is 4, and yeah, now again we're gonna check if minimum, also don't forget to push. So what were required to push 9 here, right? We pushed 9, we are pushing number, right? Now we'll check if minimum is greater than top element of stack. No, our minimum 4, it is not greater than top element of stack. Now what we are required to check, I want to show you this, that here our I is the smallest, I is here 4, right? Our k is here, that is 9, right? Now what we checked, that 4 is less than 9, that we checked. Now what we are required to check, if our j is greater than 9, right? Our j is supposed to be greater than 9. So what will be our next step? If that passes, if our j value is greater than top of stack, if that's the case, that means we got our answer. We are gonna simply return true, right? So here, as we can see, that 4 is 4 is not greater than 9, right? 4 is not greater than k. It is supposed to be the largest. So we are going to do nothing. We are gonna get here, or I is gonna get here, or j is gonna get here to the next element, and then we are gonna push 4, right? So now our k is 4. Okay, so our k is 4. Now we are gonna check first condition, if 5 is greater than the top element of our stack, right? So 5 is greater, so we will simply pop it. Again, if 5 is greater than a top element of a stack, no it is not, then the second condition, I want to show you this. So what we checked, that 5 is greater than top element or stack. 5 is I and k is 9, so it matches, right? Now for j, we are required to check if j value is greater than the top element or stack, right? So j is 10 and it is greater, so it matches the 132 pattern condition. It matches, so we are gonna simply return true. Perfect. So that's how we are going to calculate. Let's see more example. Let's say we are just given 1 3 2 4, right? We are traversing from right to left. Here is my stack. First I'm gonna push 4, right? Because I know for 4 there is no right element, no k. Now I got at 2, right? So First, we forgot to calculate minimum. So for here, the minimum is 1, 1, 1, 1. Right. So we checked if 1 is greater. No, 1. Also, let me bring the steps here so that you could relate. Right. Wait a minute. Yeah. Okay. Yeah. Okay. So we pushed 4. Now we get to 2. Right. Now we are required to check if minimum is greater than the top element of our stack. No, minimum is not greater. Right. Then what we were supposed to check? Minimum is not greater, right? So we are supposed to check if 2 is greater than 4. Right. But 2 is not greater than 4. Right. 2 is not greater than 4. Then we are going to simply do nothing. Right. And now our j will be at 3. Right. Now our j is at 3. Then again we are going to check the minimum condition, and it satisfied the minimum condition. 1 is less than 4. Now we are going to check if 3 is greater than 4. No, it is not greater than 4. Right. We are going to do nothing. Right. Okay, earlier we forgot to push it. First we had to push 2, and now we are pushing 3. Now we get to 1. Right. Now we checked if 1 is greater or equal to 1 is greater or equal to a top element or stack. Right. So our minimum 1, it is less than, so that means what we got, our I is 1. Right. Our k is top element or stack, that is uh we popped it, right? Yeah, I think we did something wrong here. Our k is 2, right? And our j is at, never mind. Okay, so okay. Let me undo it. Yeah, so we were at j is equal to 3, right? We were at j is equal to 3, and in the stack we pushed 2 here, right? We in the stack we pushed 2. Now understand, we are at j equal to 3, and we know the minimum, that is our I. Our I here is 1, our j is here is 3, and our k here is a top element, that is 2. Now I checked if minimum, that is 1 is not greater than the top element of our stack. So that means first condition is true, right? I don't have to pop anyone. Now I want to check if j is greater than k equal to 2. And yes, that's the case, so I will print true. Okay. I hope that you understood what I am trying to convey. So now let's get to code and you will eventually understand it. So here it is. First, we will be needing a minimum array, right? So let's create a minimum array of n size. So I know the minimum till now array, right? So the minimum of 0, the 0th index, what will be it? It will be itself, right? So nums 0 minimum is equal to num 0. Now I'm gonna traverse starting from I is equal to 1 till n I plus plus. So minimum of I will be equal to mat dot minimum, whatever is minimum. Minimum till now, that is I minus 1, and my current value minimum. Now we are given nums I. So we calculated a minimum. Now of course we will be requiring a stack. So I will create a stack integer. I'm gonna call it st equal to new stack. Okay, now I'm gonna traverse, and we know that we are required to traverse from right to left. So in j is equal to n minus 1, j is greater than equal to 0, j minus minus. Now what? Now I know that to follow my steps, I'll be required minimum. Right? We are required to compare from minimum. So I'll be needing a minimum. So int min equal to min array. We get it min array, right? Here it is min array, of course. Else min array, right? So int min equal to min array j, right? Now I got to compare. I got to check while first condition if stack.size is greater than 0. If stack.size is not equal to 0, and if minimum is greater or equal to the top element of my stack, st.peak. If that's the case, then what I was supposed to do is do nothing and simply pop. Right? We were simply pop. Now, if we are here, that means that minimum is not greater this time. So what we are required to check, the first step, if stack.size is greater than 0, of course, and let's see what was it, and j value is greater than the top of stack. So we need j value. Here it is index. So I'm going to create a variable here, int j val, that is equal to num j. Perfect. So now here we will check if j value is greater than what? Greater than st dot peak. Greater than st dot peak. So if that's the case, that means I got my answer. So for my storing my answer, I will create a boolean variable here, found. So if that is initially false. So if I found my answer, right, I'm gonna make found is equal to true, and I'm gonna simply break, right? And here, of course, our last step was to push. So let's push the value nums j, and then simply print found value system.out.println found. Okay, let's full screen it. Okay, now let's try to run our code. Okay, thing. Okay, let's try to run it. And if there is any error, let's fix it. So 26 line. If st dot, okay, 2 times. Typo error. Okay, let's try to run it again. True, let's try to submit it. As you can see, it passed all the test cases. So that's it for this question. If you liked this video, we discussed multiple approaches this time. So if you like this, do not forget to like, comment and share. Thanks for watching.